types of problems to be on our quiz that most of us took yesterday?
No.
Okay, good.
We learned this yesterday.
Okay.
I wouldn't teach something and put it on the quiz, 2 minutes later. That would be mean. All right, so number 1 is 30. Number 2 is 4 square roots of 3. Number 3 is 23 over 2. Or if you wanted to make it 11.5, I'd be okay with that. Number 4 is 22 square roots of 3. Number 5 is 16 square roots of 2. Number 6 is 36. Number 7 is 16. Number 8 is 10 square roots of 3. Number 9 is 9 square roots of 2. Number 10 is 8 square roots of 2. Number 11 is 52 square roots of 3 over 3. And number 12 is 16 square roots of 3. Yes, ma'am.
Can you repeat 8?
Yes, 10 square roots of 3.
Can you do 8?
Sure. So first, what type of triangle do we have?
A 30, 60, 90 triangle.
Right. Which side do we have?
The long side.
Be real careful about saying long side, because the long side would be the hypotenuse.
The longish side.
What you really mean is the long leg.
That.
Okay. So what do we do with the long leg to find the short leg?
You multiply it by the square root of 3.
Except we're going from long to short, so we won't multiply, we will divide. So it's 15 divided by the square root of 3. And then we'll rationalize the denominator. And we get 15 square roots of 3 over 3, which is 5 square roots of 3 for the short leg. Then how do we get from the short leg to the hypotenuse?
Times it by 2.
Yeah. So that'll be 10 square roots of 3.
Okay.
Hey, are there any other questions on the front? Yes.
One's a general question, then one's my problem.
General question.
Number 5, is number 5 formatted the same way as number 8?
No.
It isn't?
No. I don't think I stuttered.
Sorry. Did you do... Am I allowed to ask you to do 3 problems?
Okay, pick one. Let's go while we're young.
Can you do number 1, please?
Okay. So what kind of triangle is that?
I'm not sure. Because it didn't give us angle measures. Was it a... I don't know. I thought it had like a...
What is that the symbol for?
What symbol?
The one, oh, sorry, I forgot that I didn't have my screen on. My fault. I was trying to give you a hint. 3, 2, and...
It's a right triangle.
It's a right triangle. So it's not 30, 60, 90. It's not 45, 45, 90. So what do we use?
Pythagorean theorem.
Exactly. Is that what you did?
No.
Okay.
I thought it was a perfect third. And so I did...
You mean a Pythagorean triple?
Yeah, that.
Okay.
I'm sorry. I don't know where I got perfect third from.
So this is 6 times 3, and this is 6 times 4. So this should be 6 times 5, which is
30.
30.
I literally have that written down, but then I got 13 square root of 73.
Okay.
Oh my goodness.
So you had another question you wanted to ask?
Yeah. I have 2 more, but I think Sammy has another.
Well, go ahead and ask another one, then I'll give Sammy a turn, then we'll give you another turn.
Can you do 10, please?
Sure.
Sharing turns is carrying turns.
So what kind of a triangle is this?
The right triangle.
Right. So what did you do for this?
I simplified 14 and 18, and I made it 2 times 7 and 2 times 9.
You factored.
Factored, my bad.
Okay. So this is going to be 2 times something.
And then I did 7 squared plus 9 squared plus x squared.
Where's the hypotenuse?
Oh, Oh my goodness. That's why I got it wrong.
So 7 squared plus b squared is equal to 9 squared.
Oh no.
So 49 plus b squared is 81. So b is the square root of, what is that? Is that 32?
Yeah.
And then we have to simplify the square root of 32. This doesn't happen very often, that you can simplify once you have factored something out like that, but it does happen now and then. The square root of 32 is the square root of 16 times the square root of 2. So that's 4 square roots of 2. So this is 8 square roots of 2. Okay? Sammy.
You can go with Marion. I'm trying to figure out this one.
Okay.
Can you please do 5?
Okay. What kind of a triangle is number 5?
45, 45, 90 triangle.
Right. What side do we have?
One of the legs.
We have one of the legs. That's well said. So then, how do we find the hypotenuse from one of the legs?
Since it's an isosceles triangle, the two legs are congruent.
Right. So this is 16, but I don't care about that.
16 times 2.
No.
Does that only work if it's not a 45, 45, 90 triangle?
Yeah, you never, in a 45, 45, 90, if you did that, this would be 32, right? Let's stop right there. That's not a triangle.
Oh, it would be a straight line.
Exactly. So it's not times 2, it's times the square root of 2.
16 square root of 2.
Yes.
So the multiplication by 2 only works if it's a 30, 60, 90?
Correct. The short leg times 2 gives you the hypotenuse. Okay? And that's because, again, I keep coming back to this, but if it helps you remember it, if you start with an equilateral triangle where all these are 16, the short leg is 8. So the hypotenuse is twice the short leg.
That makes more sense.
Okay? All right, any others? Yes.
Was the answer for 1152 and the square root of times the square root of 3 over 3?
Yes.
Okay. And then was 7 6 square roots of 46?
7. No.
Can we do 7?
Yes. So what did you do on 7?
I multiplied. I'm not looking for the hypotenuse, right?
That's correct. You're not looking for the hypotenuse.
Okay, never mind.
Gotcha. Any other questions on the front? All right, then on the back, number 13 is 2 square roots of 41. Number 14 is 5 square roots of 3. Number 15 is 15 over 2, or 7.5. Number 16 is 13 square roots of 3 over 2. Number 17 is 6 square roots of 2. Number 18 is 17 square roots of 2 over 2. Number 19 is 26 square roots of 2. Number 20 is 2 square roots of 65. Number 21 is 12 square roots of 3. Number 22 is 10. 23 is 20 square roots of 3. And 24 is 7 square roots of 2. Questions about any of those? Yes?
Could you please do 20?
Yeah, absolutely. All right. So for number 20, when we draw in the diagonal in a rectangle, what kind of a triangle is this triangle over here?
30, 60, 90?
How do you know that?
watch the lesson.
Didn't watch very closely then, because it's not.
No,
Nope.
it's not a 30, 60, 90 triangle.
Why would it be a 30, 60, 90?
What is
It could be, but actually know conclusively that it's not.
Why?
Because if it was a 30, 60, 90 triangle and the short leg was 8, the long leg would be 8 square roots of 3. And the long leg is 14. Those two are not the same. So it's just a,
Right triangle.
so what do we have to use?
Pythagorean.
Exactly. I would factor both of these by 2. This is 2 times 7 and 2 times 4. So x will be, and I always write this down, 2 times something, because it's really easy to do the problem and forget to multiply by 2 at the end. So it should be 2 times the square root of 65. I'm sorry? But then didn't do it. And so that is the one drawback to doing it by factoring out the number. Although it does keep your numbers smaller, if you forget to put it back in, then you can have problems. Yes?
That's why we put 2 there.
Yes.
Oh my goodness.
It's going to be 2 times something. It's going to be 2 times the square root of 65.
Okay.
Yes.
Could you? I have a general question. If there's a number that isn't divisible by 2 on the bottom, but I put it as 6.5, do you not want me to do that?
It's okay.
Okay.
As long as it doesn't have a square root associated with it. Oh, you're talking about number 16, right?
Yeah.
No, we do not do that.
Okay.
Because we typically, it's standard in math not to mix a decimal with a square root if we can avoid it.
Okay. And can you do 22 and 23?
Okay? So tell me what you did on 22.
I did 26 to the power of 2, and 24 equals 24 squared plus x squared.
Okay.
And
26 squared is?
652.
676.
Oh. Yes.
You're in the neighborhood, but you were totally at the wrong house. And 24 squared is 576.
I got 526 for that too.
You have the same number?
So 6 times 6 is what?
36.
So you must have done something else wrong. I don't know what.
Oh, I put 2. 6 times 6 is apparently 12.
Ah, you did 6 plus 6.
Yeah.
And we can save yourself all that problem by factoring these. This is 2 times 13. This is 2 times 12. So this is 2 times something. Oh, it's 5. It's a 5, 12, 13 triangle.
Okay.
Okay? All right, then on this one, tell me what you did, please, ma'am.
I figured out that it was a 30, 60, 90 triangle.
Great. Go on.
And then I did 30 to the times the square root of 3.
But you're going from the long leg to the short leg.
30 divided by the square root of 3.
There you go, 30 divided by the square root of 3. So then we multiply by the square root of 3 over the square root of 3. We get 30 square roots of 3 divided by 3. I can reduce that to 10 square roots of 3 for this piece. So then all of x will be twice that, will be 20 square roots of 3. Okay, any other questions? Okay, if you would please, yes?
I have a general question that isn't about this lesson.
Every time someone says general question now, Colton looks at me, waits for me to salute.
When we're figuring out if a triangle is acute or obtuse, does a squared plus b squared is less than c squared? It's acute?
If the big side is too big, it's obtuse. Think about it that way. So if c squared is bigger than a squared plus b squared, that's obtuse.
Okay.
If the big side is too small, it's acute.
And if they're equal, it's right.
If it's just right, it's right. Yes.
Is the a squared plus b squared are the first two numbers?
I'm sorry?
Like,
No, c has to be the biggest side. It's never first two, last two, anything like that. C's got to be the biggest side.
okay.
All right. So, a little bit more practice with using right triangles. Not a super long set of notes for today, but let's see what we can do. Find the length of each side of an equilateral triangle if the altitude, which is what you sometimes will call the height, and again, I think I pointed it out the other day, but if you get technical, height is the length of the altitude. But we use them kind of interchangeably, and that's okay. So, got an equilateral triangle. Da-da-dee, da-da-dum, da-da-dum-dum-dum-dum. And the length of the altitude, or the height, is 12 square roots of 7. So, what side of this 30, 60, 90 triangle do we have?
The long leg?
Right. How do we know it's the long leg?
Because it's opposite the angle measure of 60.
Perfect. So the short leg, how do we find that? What do we do to the long leg? Divide by the square root of 3. Thank you, sir. We can't reduce that. We can't leave the square root of 3 in the denominator, so we'll multiply by the square root of 3 over the square root of 3.
Would it become square root of 21?
Yeah, 12 square roots of 21 over 3, which will be 4 square roots of 21. Now, is that a side of the equilateral triangle?
It's half of a side.
It's half of a side, so the whole side is?
8 square roots of 21?
Exactly right. One of the most irritating things in the world is when a student on a quiz or on a test calls me over, says, "Can you look at this problem?" Sure. And they say, "Which side do you want?" I said, "I want a side of the equilateral triangle." "Yeah, but which one?" "I don't care. Pick one." "But they're not the same." "Really?" "I want a side of the equilateral triangle." "Yeah, I know. There's two different ones." Okay. I just shake my head and walk away. All right. So that's like problems you've already done. So is this one, it's just they didn't draw the picture for you. Find the length of each side of a square if the diagonal is 26. So let's draw a square. Make the length of the diagonal 26. What kind of triangles are these?
Right triangles?
More specific.
45, 45, 90 triangles?
Yep. In a square, these are always 45, 45, 90 triangles. So what do we do to the hypotenuse to get the legs?
Divided by 2. By the square root of 2.
Divide by the square root of 2. We can't reduce, and we can't leave a square root in the denominator. So we're going to rationalize and get 26 square roots of 2 over 2, which is 13 square roots of 2. Okay, any questions about that?
Mr. Davis,
Ma'am,
do you like the Nutcracker, or do you think it's boring?
I think it's boring.
Yeah.
I mean, I like some of the music, but the ballet itself
It's
is
so boring. They're
so
long.
boring. Oh, and it's incredibly long.
Like, good for them. They're very talented, and the music's cool. But it's so boring to just watch them. There's no words.
The mouse always scared me, like the Mouse King. It would come out with all of its other mice friends and dance around. It freaked me out.
Yeah, I did actually. I mean, I've watched it, you know, the whole thing in person once, and I was like, oh, never again, because it's deadly dull. And like you said, great, you're very talented. That's not something I could ever begin to imagine, you know, being able to do, and yet the story is just not good enough.
I don't even get it. Like, what's going on there?
It's all a dream that a little kid is having.
I never knew that.
I've never seen the Nutcracker.
Oh, like they're dreaming on Christmas Eve, and that's their dream.
I never knew that.
At least that's the way I interpret it. That may not be the most common interpretation, but I'm like, this is a dream some little kid has.
My parents have played in that for like every year ever, except for like the last 2, and I never knew that.
I like I said, I could be wrong. It's been a long time. All right, so let's take a look at these two problems. We are going to use this diagram twice. I'm going to redraw it for the second one, or you should when we get to that. So it says the length of RS is 16. What is the length of QT?
We can find the short and long sides of triangle.
Wait. I'm going to stop you. 16 is the long side. You don't mean the long side.
The long leg.
Thank you.
It's
Go
the
ahead.
leg. And then we can use that to find, and that will be the long leg of triangle RQT, which will help us find the short leg.
Okay. Do we really need to find the long leg of the triangle on the right?
No, short leg.
We just need the short leg. How long is the short leg going to be?
8.
Yeah, half the hypotenuse, so it's 8. And then from there to get to QT,
We have to divide
by,
square root of 3.
divide by the square root of 3. Can't reduce, so I'll rationalize. It's 8 square roots of 3 over 3. Pardon?
That's fast.
Yeah. All right. I'll give you a second. Go ahead and redraw that. Put all the letters on it and everything. All right. So we're given here that the length of RT is 10, and we're asked for the length of QS. There are a couple of different options that you could use to find that. I'll take a suggestion about finding anything. Yes?
You could find the length of QT and then TS and add them together.
Okay. One way to do it would be to find the length of QT and find the length of TS and add them together. Let's do that. So from here, RT to QT, we're going from long leg to short leg. So what are we going to do?
Divide by
Divide by what? Square root of 3. So again, we'll rationalize the denominator. So that's 10 square roots of 3 over 3. And then to find TS,
RT is the short leg.
right?
And you can multiply it by the square root of 3
Perfect.
to find TS.
So TS is 10 square roots of 3. Yes, but not until we do a little work first. So QS is going to be equal to 10 square roots of 3 plus, or 10 square roots of 3 over 3 plus 10 square roots of 3.
Can we multiply 10 square roots of 3 by 3 to get 3 out from the denominator?
No. If you're going to multiply something by 3, you've changed its value.
3 over. Can we multiply both by 3?
Well, then you'd have to multiply QS by 3 also. You could. There's a more straightforward way. If you're adding two numbers together and one of them's a fraction,
Make them both a fraction.
yeah, make them both a fraction with a
Common
common denominator.
So it'd be 30 square root of 3
Over,
3.
right. So this would be 10 square roots of 3 over 3 plus 30 square roots of 3 over 3 is 40 square roots of 3 over 3. Now, before we go on to the back, there's another way that we could have done that. Well, let's take a look. Let's go ahead and continue in the triangle on the left-hand side. How can I find the length of QR?
It's the hypotenuse.
Of this little triangle, so what do I do?
Here, you have the long leg, so you have.
We also have the short leg.
We've got the short leg too.
Oh.
Multiply the short leg by 2.
Right. 10 square roots of 3 over 3 times 2?
20 square roots of 3 over 3.
Yes. Now, turn your attention to the whole big triangle, which is also a 30, 60, 90 triangle. What side of that 30, 60, 90 triangle do we have?
The
Short leg.
The short leg.
And the hypotenuse.
So how do I get the hypotenuse?
Times it by 2.
Multiply by 2.
Is this the number?
It better be. That's the kind of thing where it's like, we've done this legally both ways. If we don't come up with the same answer, something's wrong somewhere. All right, let's go on to the ones on the back. So number 1 on this, on all these, it's asking for the perimeter. So let's real quickly, how do you find the perimeter of any polygon?
Length
Add all the sides.
Yeah, add the lengths of all the sides. What's the problem with number 1?
We don't have all the sides.
Okay, we don't have all the sides, so we need to find the sides. So what kind of a triangle is this?
30.
Not a special triangle.
It's a 30, 45, 105 triangle. And you're like, what the heck, Mr. Davis? I don't know any rules for that.
Are there any?
No.
Okay.
So what do? Well, one of the themes that's going to come up a lot for the rest of the year is if you don't have a triangle, a right triangle, make one. I am going to do what's called dropping in an altitude.
Oh, shoot.
Just like that. Sound effects are optional.
They're not optional. They're mandatory.
So now we've got two triangles, and this one is a
45, 45, 90.
right, and this one is
30, 60, 90.
the 30, 60, 90, and we have rules for those. So in the 45, 45, 90 triangle, we've got the hypotenuse. How do we find the leg?
Hypotenuse divided by 2 is short leg. Divided by square root of 3. Oops.
Square root of 2.
Oh, shoot. Got it wrong twice.
We can't reduce, so we'll rationalize. So it's 24 square roots of 2 over 2. We can reduce that, so both of these legs are 12 square roots of 2. Now we'll switch over and work on the triangle on the right.
Would we multiply 12 square roots of 2 by 2?
To get what?
The hypotenuse?
Yes. So that's 24 square roots of 2.
And now we have to find the long leg.
Got to find the long leg. How are we going to do that?
Divide 12 square roots of 2 by the square root of 3.
We're going from short to long.
Times it by the square root of 3.
Yeah, multiply by the square root of 3. So this is 12 square roots of 6.
And we have to add it to 12 square roots of 2.
So we've got to add all of these pieces together.
Oh, shoot, yeah.
So
the perimeter is going to be 24.
wait, how did you get that? Oh, I see. Never mind.
Okay. So there's a 24. There's a 12 square roots of 2 plus 24 square roots of 2 is 36 square roots of 2.
What about the other 12 square roots? Oh,
And a 12 square roots of 6.
is it like a different? Can we not add them up because they're not the same?
Exactly right. It's like adding 36x and 12y. You can't combine them because they're not like terms.
So that it?
That's our answer. So you do have to be careful about saying you can't add them. We are adding them. It's just that we can't combine them when we add them.
Okay.
Do you see what I'm saying? All right. Let's look at number 2. By the way, what kind of a figure is that?
A shovel.
A trapezoid. More specifically,
Rhombus.
a rhombus is not a trapezoid, ever.
It looks like an upside down sailboat to
Parallelogram.
me.
Parallelograms are not trapezoids.
And
Okay, it's a type of trapezoid. It's got these two legs are congruent.
Isosceles trapezoid.
This is an isosceles trapezoid.
That's a thing.
what?
Yep.
Does that mean that the two bottom angles are congruent?
In fact, it does. We won't use that right now. Well, actually, we will. Because what we're going to do is make right triangles because we don't have any right now, do we?
Can we make little ones from the top edge down to the bottom? Oh my.
In fact, we will. We'll drop in an altitude here and an altitude here. Well, what does that make in the middle?
A rectangle.
A rectangle. So this piece is 16.
So do we know that two opposite ends are now going to be 4 and 4?
Yes. How do I know these two triangles are congruent?
Because we dropped them down in the same
And
place at
isosceles.
16.
So that means that this piece is congruent to this piece, right?
Mhm.
Oh, sorry.
Not side angle side.
Angle side angle.
Nope.
Side angle. Oh, no.
Side angle angle.
We don't know that this angle is 60 yet.
Angle,
I thought
side.
we said it was.
Angle.
We're justifying why it is.
Oh,
Outside.
Trapezoid theorem.
Yes, there is an isosceles trapezoid theorem, but we don't know it yet.
Definition of it.
Wait,
Oh,
outside.
my
X
question is,
two.
why are these two triangles congruent?
Oh, yeah.
Right triangle theorem. Definition of right
Okay,
triangle.
please stop guessing. Seriously.
Oh, the hypotenuse leg.
Yeah,
thing.
it's hypotenuse leg. They're both right triangles. The two hypotenuses were given as congruent, and we know that these two segments, because they're perpendicular to this line and these two lines are parallel, have to be the same length. So that means that this angle is 60 also. So these two triangles are congruent to each other. And as you said, since this piece is 16, from 24 leaves 8, that means this little piece is 4, and this piece is 4. So in a 30, 60, 90 triangle, how do I find the hypotenuse from the short leg?
Multiply it by 2.
Right, so this is 8. be really careful on the perimeter on this one. The sides are 8, 16, 8, and 24. It's really easy because you've written these 4s on the ends to accidentally add them in. We know that this whole thing was 24 before we started. So 16, 16, 32, that's 56. All right, one last one. So the whole figure here is a
Rectangle.
rectangle. What kind of triangles do we have?
Congruent
Right
ones.
triangles.
Congruent right triangles. Between the two of you, got it right. Congruent right triangles. So, okay, that means this is 14, but how in the world am I going to find these two sides?
By the Pythagorean theorem.
Exactly. And both of these are divisible by 2, so I'll factor this to 2 times 10, and this to 2 times 7. So this will be 2 times something. So 7 squared plus b squared is equal to 10 squared. So that's 49 plus b squared is 100. So b is going to be the square root of 51. And although that's divisible by 3, 3 goes into that, what, 17 times? I'm not going to have any like factors, so this doesn't simplify. So this is 2 squareds of 51. So this side is also 2 squareds of 51.
Since they're both 2 square roots of 51, would it be 4 square roots of 51?
Indeed. So this is 28 plus 4 squareds of 51.
Is our homework tonight a worksheet?
Yes, I told you guys this whole unit was worksheets.
Oh, sorry, I forgot.
It's okay.
Very good. Why is it working?